Picture this, a vast field of golden wheat, swaying gently in the breeze. But beneath the surface, an invisible revolution is taking place. Tiny sensors, scattered throughout the soil, are silently gathering data that could change the face of agriculture forever. This is the cutting edge of smart farming, where technology meets tradition to feed the world. Welcome to the Fields of Innovation YouTube channel. Smart farming starts here. Discover the future of agriculture, where we share information about technology applied in agriculture. Today, we're diving deep into the world of soil moisture and nutrient sensors, the unsung heroes of precision agriculture. These small but mighty devices are transforming how we grow food, making farming more efficient, sustainable, and productive than ever before. Precision agriculture is all about using technology to optimize crop growth and resource management. Instead of treating every inch of a field the same way, farmers can now target specific areas based on real-time data. This is where the Internet of Things, or IoT, comes into play. Devices like soil sensors, drones, and weather stations are now able to communicate with each other, providing farmers with insights that were once impossible to gather. So, what exactly are soil sensors? Think of them as the field's own health monitors. These electronic devices are designed to measure various physical and chemical properties of soil. Their main job is to provide farmers with data that helps them understand soil health and make better decisions about how to care for their crops. There are several types of soil sensors, each with its own specialty. Moisture sensors track the amount of water in the soil, helping farmers avoid over or underwatering their crops. Nutrient sensors detect key elements like nitrogen, phosphorus, and potassium, which are essential for plant growth. And temperature sensors measure soil warmth, which can greatly influence seed germination and root development. Now, let's get into the nitty-gritty of how these sensors actually work. Soil moisture sensors, for example, are pretty clever devices. They measure moisture by analyzing how water changes the soil's ability to conduct electricity. There are a few different ways they can do this. Resistance sensors measure how easily electricity moves through the soil. Wet soil conducts electricity better than dry soil, so these sensors can give a good indication of moisture levels. Capacitance sensors, on the other hand, detect changes in the soil's dielectric constant as water levels fluctuate. And then there are TDR sensors, which send an electrical pulse through the soil and measure how long it takes to reflect back. The longer it takes, the more moisture is present. What's really cool is that many of these sensors are connected wirelessly to a central system. This means farmers can check soil conditions instantly on their smartphones or computers, no matter where they are. But moisture isn't the only thing these sensors can detect. Nutrient sensors are equally important in smart farming. They focus on measuring the presence and concentration of three key macronutrients: nitrogen, phosphorus, and potassium. These elements are like the vitamins of the plant world, absolutely essential for healthy growth. Nutrient sensors use some pretty sophisticated methods to do their job. Electrochemical sensors, for instance, use ion-selective electrodes to detect specific nutrients in the soil. It's like having a tiny chemistry lab right there in the field. Optical sensors take a different approach. They shine light into the soil and measure how it reflects back, giving information about nutrient levels based on the light's behavior. All this technology is great, but it's how these sensors integrate with larger smart farming systems that really makes them shine. Many sensors are linked to cloud-based platforms via Wi-Fi, LoRa, or even satellite networks. This makes the data accessible from anywhere in the world. Imagine a farmer sitting at home, checking their phone, and seeing that soil moisture has dropped below a certain threshold. The smart farming system can automatically trigger irrigation, ensuring crops get exactly the water they need. Similarly, nutrient data can inform precise fertilizer application, reducing waste and saving money. The benefits of using soil sensors are huge. They lead to improved water efficiency, as farmers can avoid over or underwatering their crops. This not only saves water, but also reduces energy costs associated with pumping and irrigation. Fertilizer use is optimized too. By applying fertilizers only where and when they're needed, farmers can lower their costs and reduce pollution from runoff. All of this adds up to higher crop yields and a lower environmental impact. Healthy soil leads to stronger, more resilient crops. At the same time, the reduced use of water and chemicals protects local ecosystems, making farming more sustainable in the long run. These aren't just theoretical benefits. Soil sensors are making a real difference on farms around the world. In the U.S., large corn farms in Iowa have used soil sensors to cut water use by up to 30%. Over in Canada, vineyards in British Columbia are monitoring soil conditions to improve grape quality, leading to better wines. In the UK, greenhouses are relying on nutrient sensors to grow vegetables year-round, even in less than ideal weather conditions. And in drought-prone regions of Australia, soil sensors are helping farmers survive and thrive despite water shortages. It's not just individual farmers embracing this technology. Many governments now support soil sensor programs with grants and incentives. Recognizing their potential to revolutionize agriculture, at the same time, agri-tech startups are working hard to scale these tools, making them more accessible for commercial use. Of course, like any new technology, soil sensors come with their own set of challenges. The upfront costs can be high, especially for small farmers. There's also the need for regular maintenance and calibration to ensure accurate readings. And in some remote areas, the infrastructure needed to support these smart systems might not yet be in place. But the future looks bright. We're already seeing the development of next-generation sensors that are more accurate, durable, and affordable. And as artificial intelligence continues to advance, we can expect to see AI-driven predictions becoming a big part of smart farming. Imagine systems that not only measure current soil conditions, but can forecast changes and recommend actions automatically. In conclusion, soil sensors are more than just cool gadgets. They are key to sustainable farming in the 21st century. They allow farmers to grow more food with fewer resources, which is critical for feeding our growing global population while protecting the planet. We'd love to hear your thoughts on this exciting technology. Have you had any experience with soil sensors on your farm? Or maybe you have questions about how they might work in your specific situation? Drop a comment below and let's keep the conversation going. And if you want to stay up to date with the latest in agricultural technology, don't forget to hit that subscribe button. Remember, smart farming starts here on the Fields of Innovation channel. Until next time, keep innovating.